duration curve that is extended very close to 0. If you have a flow duration curve that starts from 1, it starts from a duration of 1 day. It means that it starts from something that occurs on average once in a year. It cannot be called a flood. Okay? If you have a flow duration curve that it's based on a long observation period, and therefore you get the flow duration curve according to this second computation method defined up to a duration that is close to 0, then it may be representative of a flood. But still, I would keep the concept that the flow duration curve is not representative of floods. It's representative of high flow, low flows, river flow regime, but not floods. And keep in mind that when you design a water withdrawal, water resources management, you have to take different methods with respect to when designing something related to floods. So if you design an infrastructure for water resources management, you use one method, the flow duration curve. If you design an infrastructure against a flood, you take another method, which could be an analysis of the extreme events. The flow duration curve, it's an analysis of the standard events, not extreme events. Okay, now the question is, let's suppose that you have your flow duration curve. How can we get the design variable for the infrastructure that I need to project? How can we get to design water withdrawal? There are several methods recommended for identifying, basing on the flow duration curve, the design water withdrawal, depending on the water use. So if you design a water withdrawal for a water supply system, it's a different story with respect to designing a water withdrawal for an hydropower plant. And keep in mind that, in general, the design variable for an infrastructure that aims to withdraw water comes from an interplay of two analyses. The first is the analysis of water resources availability, and the second is the analysis of water demand. So usually you need also to estimate water demands, of course, when designing a water withdrawal. But in most of the cases, you will find that the demand is much higher than availability. And therefore, your design is conditioned by water resources availability and not by demands. And you may say, why is that? Because, water resources management becomes a problem when you don't have enough water. When you have plenty of water, usually water resources management is not a problem. And in fact, water resources management as a science was born about 30 years ago, starting from 1970. But in the modern structure, the water resources management was born in the 90s. It was not a problem, water resources management, more than 50 years ago, because the water demands were much lower and water resources availability was much higher. Then water became polluted, and then water demands increased, and the people started to experience the problem of water scarcity. And therefore, water resources management became a need and was born as a science. Not really as a science, but as a branch, as a discipline. The science is hydrology, and the discipline is water resources management. And therefore, in most of the cases, if you are asked to make this analysis, if you are called into play, the problem is that you have demands that are higher than water resources availability. And therefore, we are conditioned indeed by water resources availability. We are conditioned by the need of taking as much as water as possible. As much water as possible. without negatively impacting on the environment, without overexploiting water resources, of course. This is why we focus on estimation of water resources availability to design water supply system, to design hydropower plants, because this is usually the conditioning factor. On the other hand, you don't have to forget that estimation of water demands is an important component of the analysis. We are not focusing on estimation of water demands because usually this is the subject of other courses. So if you have courses on practical design of water supply systems, they focus on water demands. It is quite easy, based on your estimate of demographic increase. There are standard water needs codified depending on the context that allow you to quantify water demands. The conditioning factor, again, it's in most of the cases not water demand, it's water resources availability, and this is why I'm focusing on it. So let's now make a break, 15-minute break, and then we will move forward with estimation then of the design variable for water withdrawal based on the flow duration curve.